Now we will see that total Rout and the VRL voltage for this transistor. So I am taking ADE-XL because that will be very much easier to operate for this kind of parameters, to analyze this kind of parameters. I'm creating my new ADE-XL view. So this is my ADE-XL. So from here I will take my test, the initial test I will add. So this is my test. Okay, the same thing I will do here. I will set up my model libraries here, and I will select TT_18 from the section. Okay, the design variable I'll set to the 1.8, the exactly same thing that I have already done. So I think I have taken here, and I'll take my analysis from here. The simple DC analysis I'm taking from here. Okay, apply. Okay, and the output I will take from this node. So my ADE is okay now. I'll go back to my ADE-XL again. So here, see, M0D signal point, this thing is there. So now from the global variables, that is my global variables VDS and VGS, and this is my parameters. Let us take that VGS, not 1.2, 600 milli. Okay, then I will take kind of 800 milli. Then I will take 1 volt, 1.2 volt, 1.4 volt, 1.6 volt, 1.8 volt. Okay, so this is it. So now if I run the initial simulation, so you can see there is different parameters are there, that VGS 600 millivolt to 1.8 volt that I have chosen here as the VGS. Okay, so one thing I just skipped from here, so I need to select that VDS also from here, not the component parameter, design variable. Okay, so I have chosen the global variables. VGS I am sweeping, so I'll choose VDS from here. Okay, and I'll put 0, 1.8, apply. Okay, minimize the test editor, and now again I will run the simulation. So now if I click on this plot window, see here, all the plot came, the parameter analysis. So this is how we can operate ADE-XL for the parametric analysis. So this is a little bit easier, okay, for that thing that I have shown you in that from the tools parametric analysis section. Now we will see how to calculate the Rout and the VRL voltage for the transistor. So from here I can go directly to the calculator. So if I am going to the calculator, this OS you need to select, DC operating point sweep. Okay, now if I click on list, there is nothing is there. So why is nothing is there? So I need to select the transistors also for that. So for that I am selecting this transistor. This is the NMOS transistor, and if I am just go back to that pop-up, so here if you just click on list, there will be all the parameters listed here. So from here we will select the VRL. Here you can see VRL mentioned. So VRL, okay, and we will go back to the calculator again. So here the VRL is there, VRL voltage is there. So for the channel length modulation, we will put 1 divided by the VRL voltage, and we will send the expression to the buffer. So in my ADE, 1 by VRL is there. Similarly, I will take the Rout also. So again I will press OS, and I will come here. I will select the transistor, and then I'll go back to the OS parameter selection window, and from here I'll select Rout. Here you can see Rout is there. Okay, I'll click on OK. Then I'll go back to the calculator. So here Rout is here, so I'll send it to the ADE. So now if I close the calculator from here, and if I go to the ADE-XL, so here you can see the Rout is also there, and the lambda value, that is on by VRL, is also there. So now if I run the simulation, I need to wait for some time. So from this plot all section, we can plot all the things that we have taken from here. So this is our lambda value, that is 1 by VRL. This is our Rout, and this is our ID versus VDS plot. So if we just try to understand the plots from here, so you can see the DC response here, ID versus VDS. Actually, what is happening? For low VDS, the transistor is in the linear region. Okay, means the ID increases the linearly, and as VDS is increasing, as I'm increasing the VDS, what is happening? It's entered to the saturation region where ID becomes the constant. Okay, near about constant. What is this graph saying? This graph helps in identifying when the threshold voltage, okay, when the current starts flowing, and the what is the saturation behavior, and what is the output resistance and the channel length modulation parameters. From this graph also we can see. Now Rout. So from this Rout, what we can observe? So actually the output resistance is low in the tried region. You can see in the tried region the output resistance is low, very low, and increases as the device enters in the saturation. Okay, it represents how strongly the transistor resists changes in VDS while delivering the current. A higher Rout means the better current source behavior. Okay. Now, from this plot, what we can observe? From this plot, that this is 1 by early voltage that I have taken from the calculator. That means I want to calculate the lambda value. What is the lambda value of this transistor? So from this plot, what we can see, the lower 1 by VRL means the less modulation. Okay, so the lower 1 by V means the less modulation, better current source behavior. So as VDS increases, you can see as VDS increases, that 1 by VRL decrease and flattens, near about flattens in the saturation region. Okay, the point where 1 by VRL stabilize can be used for the calculation of the VRL. Okay, so this is it for this video. So if you have any questions or doubt, you can always feel free to ask in the comment section. I will always try my best to help you out.